Hi everyone. So this is our first chemistry lesson, and we're going to look at Bohr diagrams, which are sometimes called Bohr-Rutherford diagrams. Bohr is named after a scientist, Niels Bohr, who came from Denmark. Really interesting person. After he went on to create this model, he did other things. So when in the 1930s, he helped some refugees escape from the Nazis, and eventually when the Nazis took over his country, later on, he was able to flee, eventually ended up in the United States and helped build the first atomic bomb. So this kind of goes to show you that scientists get involved in lots of things in the world besides just sitting in the lab all the time, and some of those things could be good and some of those things not so much. Anyways, let's move on. Learning goals. We're going to look at constructing Bohr-Rutherford diagrams for both atoms and ions. Okay, so just a quick note about these diagrams. I'm sometimes going to call them Bohr diagrams or Bohr-Rutherford diagrams. It's the same thing, so just keep that in mind. One thing to keep in mind is that the model that's used in these diagrams is useful, but it's very out of date. So we don't really use it in science now, but if you're just trying to understand some of the key important things about chemistry, like for example, how chemical bonds form, the atom can be useful in building your understanding. So we're going to be using it for that purpose. We're going to use it to explain ionic bonds and covalent bonds, which we'll talk about later. Okay, so I'm not going to run you through a worked example here. I'm going to post, there's this link to a YouTube video that you can watch that will show you actually how to construct these diagrams. It's easier for me, and also the person has a better setup, so it's going to be easier for you to follow than if I was to do it. But what I am going to do is I'm going to go over some parts of this video with you, because there are a couple of things you should know that are maybe not fully clear in the video. So let's hop over to the video. All right, so the first thing I want to mention is what you see up here. So he's going to be drawing calcium, a Bohr-Rutherford diagram for calcium in this video. So you will see this on the periodic table. If you look up calcium, it will look like this. But sometimes when I present you with a question, it won't actually look like this. You'll just see 20 on the top left, and you'll see a number in the bottom left that will be an integer. So it won't be 40 point something, it might be just 40 or 41. So this is the atomic mass, which is a number found on the periodic table. And essentially what it is it's the mass of all possible isotopes of calcium averaged out. So if you were to have a lump of calcium in your hand, which might not be a good idea, it'll react with water and irritate you possibly, but if you were to have a lump of calcium in your hand, the average mass of an atom would be 40.078, and that's because there are different isotopes of calcium in the world. Some of them will have a mass of, if we just look here, 40, some of them will be 42, some will be 48, but most of them will be 40. So you'll have the vast majority of them being 40, and then a few of them being other higher weights. And so that when you average that out, you're going to get the number that's shown in the video. You're going to get this number. Okay, but if I just give you a single isotope, it might just say 20 here and then 40 there, or it might say 20 there and then 42 there. Okay, so just keep that in mind. Otherwise, though, you do everything the same way that he is doing it. So if we forward along here, you'll notice that he does this number minus that number to figure out the number of neutrons. So the number of protons is easy, it's just this number. The number of neutrons is this number minus that number. And if instead of having the whole large number here, instead of what you have is just the integer in the corner, you still do the same thing, this number minus that number. Okay, I also want to make a quick comment about how he places his electrons around with the shells here. So he's doing it correctly, but he's just sort of doing something quickly that you might not pick up on. So what you'll notice is when he's drawing, what he does is the electrons in each shell get paired up. So in the first shell, if you have to draw 2 electrons in the first shell, you draw 1, and then you pair it with the second one. But when you move on to shells further on, what you do is you first draw electrons singly, so not paired, and then if you end up using up all the single spaces, you then start creating pairs afterwards. So what he will do is to create calcium, he actually has to fill up this entire shell. He has to put 8 electrons in this shell. So what he does is he does 1, 2, 3, and 4. There are 4 spaces for you to put a single electron. And then if those 4 spaces aren't enough, and they're not because we need 8 in this shell, then you start pairing them up after you've drawn 4. So think of it almost like north, east, south, and west. You put 1, 2, 3, and 4. And then if that's not enough and you need to keep going, start pairing them up. Okay? And do that for all the shells that have 8 electrons. You might wonder why that is. Basically, if you do it this way, it's going to help you out a lot in the future when you have to draw other kinds of diagrams in chemistry, and you have to do these things called electron configurations. It kind of goes with these ideas. So try and do it this way. I think that's everything I need to say about this actual video. Yeah, everything here looks good. I mean, I knew that before anyway, so this is a good video to watch. But I just wanted to give you some context for why the electrons work that way. Okay, one last thing I want to go over with you is what if you're not drawing an atom, but what if you're drawing an ion? So what if instead of calcium, it's calcium 2+, or something like that? So what I'm going to do is show you how to create ions with 2 examples. One with a metal that's going to create a positive ion, and one with a non-metal that's going to create a negative ion. So let's just assume that you followed that video and you're able to draw the basic Bohr-Rutherford diagram like was done in the video. How do you then convert this into an ion? So here we have magnesium, but what if I want to make magnesium 2+. And sorry, this should be a superscript, right? So it should be a small 2 and a plus on the top. But anyways, suppose I want to make this into magnesium 2+. How do I do that? Well, the protons and neutrons aren't going to change. That's still going to be the same. So I'm going to leave those there. What is going to change is we're going to lose 2 electrons. So when you create an ion, what's happening is you are losing or gaining what we call valence electrons, the outer electrons, the electrons in the outer shell. So 2+ means that you lose these 2 electrons, which might seem kind of weird. Why does plus mean lose, right? Shouldn't plus mean gain? Well, the rationale behind it is that if you count up the number of electrons that are here, you'll notice that there are 12 of them. So you have 12 negatively charged electrons and 12 positively charged protons. They cancel each other out to give you a charge of 0. So what happens if I get rid of 2 of the electrons? Well, if I do that, then I'm getting rid of 2 of the negative charges, and so they don't cancel out anymore. I have 12 positive, but only 10 negative. So if you combine those together, you get 2+. You have an excess of 2 positive charges because you have removed 2 electrons and disturbed the balance. So we're removing 2 electrons. What does that look like? Very easy. You just remove them. But you also remove the entire shell because there's nothing there. The shells actually aren't real. There is no physical shell in the real world. It's just used to kind of say something about the energy levels of electrons. So if there are no electrons there, there is no shell. So we get rid of the electrons and the shell. Okay, so we should have 10 electrons now. 2, 4, 6, 8, 10. Perfect. One last thing that we need to do. What we need to do to show that this is an ion, because it might not be that clear just by looking at it, is that we have to put little brackets around it, square brackets, and then put the charge of the ion up there. Okay, so that's done. We've got the electrons removed, we've put our square brackets, and we have our charge. Okay, what about for fluorine? Fluorine is going to be, when we turn this into an ion, we're going to be creating a negatively charged ion. We're going to have to then add electrons. And one other quick thing to note is that when this becomes an ion, we don't call it fluorine anymore, we call it the fluoride ion. So for nonmetals, when they gain electrons, you change the ending. So instead of an N, there will be a D, so fluoride. It can be a little bit confusing when you have things that don't have an N, like oxygen becomes oxide or sulfur becomes sulfide. So be careful. Make sure that you're looking up what the ending is if you're not sure. But all metals keep the same ending. So magnesium as an atom becomes magnesium as an ion, same name. But for non-metals, we have to make this change. Okay, so let's add the electron. So what I'm going to do is I'm going to kind of just cheat and steal an electron from here. And we'll move it in. So there we go. Fluoride is fluorine with an extra electron. The symbol for that would be F minus. So again, the minus should be up top, but that's F minus. So we've now added that extra electron. So now again, there's a balance that's been disturbed here. So we before had 9 protons and 9 electrons, 9 positives and 9 negatives that would cancel each other out. We still have 9 positives, but now we have 10 negatives. So we have 1 extra negative. Okay, and as you're hopefully aware, we draw the square bracket and we put in our charge, -1. Right, you can put minus or -1. Usually you'll just see it as minus. And just because you're adding electrons, you're using the existing shells. You don't have to remove or add shells. You just add the electrons. Okay, so hopefully that clears things up. Let me know if you've got any questions. It's pretty straightforward. What you're going to have to do after this is complete a worksheet. So I've given you a worksheet with questions and answers so you can kind of see how you're doing with this. And then once you feel comfortable, feel free to move on to the assignment, which you are going to need to hand in. So you don't need to hand in the worksheet. I give you the answers for the worksheet, but the assignment you will have to hand in. For the assignment, you can draw it by hand if that's easier. Right. The reason I didn't draw anything is because doing this would be difficult for me. I can just about manage square brackets, but if you want to draw it on a piece of paper and take a picture, that's fine. If you want to do it on computer, that's fine as well. All right, that's it. Take care.